Today we will have a lecture on engineering mechanics. So already in previous lectures we have solved the numericals related with engineering mechanics. So we have solved the numerical related with how to find out the x and y component and how to find out the resultant. We have seen the numericals related with how to find out the resultant and what is the x, that is the theta or the angle made by that resultant, whether it is making an whether that resultant lies in first quadrant or second quadrant or third or fourth quadrant. Okay, so you can those students who have not seen the previous numerical, they can refer the video which has already been uploaded on the my YouTube channel. So you can refer the video because that in order to find out the summation of fx or fy and to find out the resultant, it is very important numerical which I have covered in previous that is lecture. Again related with that, today we will solve some more numericals related with how to find out the x and y component. We have to have some different concept in today's problem. We will also solve some different concept in today's problem in which the angle made by the force F. Here there is a problem in which there is angles, it has been mentioned in the form of slopes. Okay, so what we have to find out, so I am reading the problem. In figure, x component of force F is 893. That means what this statement says, summation of fx or the fx is equals to, that is the x component of this force F. So here I have drawn force F. This force, it is having a magnitude of 893 newtons. Its x component, it has been mentioned as 893 newtons. That means fx in this case, it has been given as x component of this force, it has been given as 893. Okay, 893 newtons. It has been given as 893 newtons. Fx, it has been given as 893 newtons. Depending upon this, which things to be calculated, first we have to find out the y component. Before that, the angles, it has been given in the form of slope. That means it has been given in the form of 3 by 4. That is 3 is horizontal. The angle made by this force F, it is in the form of slope. 3 is horizontal, 4 is vertical. Again, there is a plane, xy plane. Normally the plane which we have seen in previous problem, it is along x and y axis, the simple graph which you have studied in that is M1 M2 or mathematics. So it is a normal graph, x and y axis. But here the plane in this, it has been changed little bit. So here this that is the line, it has been in x component, and this horizontal, it is y component. So it is little bit change in this process, and y component is also somewhat inclined and x component is somewhat inclined. That means this x and y component itself, it is making an angle. It is making an angle of, or it is having a slope of 1 by 2. Okay. So first we have to find out the angle made by this x and y. That means the plane which has been making that is 1 and 2. So first we have to find out the angle made by this. So always keep in mind while the things, it has been given in the form of slope. So we have to find out the angle in the always this angle should be made with the horizontal axis. Okay, it should be we should calculate, or it is easier to calculate the angles made with horizontal axis. Okay. So here I am giving the names. First I will give the names. So this I am giving this name as alpha, which is making an angle with horizontal axis, alpha. Next I am giving this theta. Again it is been making with angle with horizontal axis. Okay. So here this force F, it is making an angle of alpha. So first we have to find out this force F, that is by the rule of tan theta, opposite upon adjacent. And again this angle made with x and y axis, so we have to find out the angle made by x and y axis. Okay. Again one by one we will find out the angle made by this force F, and next is the angle made by this x and y axis. Okay. So it should be clear. This plane, it is along this x and y axis. So here somewhat inclined plane, it has been given x and y axis, and we have to find out this theta. Okay. We will see what is the use of this theta, what is the use of this alpha. We will find out one by one, or what is the use of these things, we will see later. Okay. So here I am finding out tan theta first. The angle made by this original plane is x and y axis. The angle made by this original plane is theta. So tan theta is equals to opposite in the sense is 1 upon 2. So opposite upon adjacent, opposite upon adjacent. Therefore theta is equals to tan inverse of 1 by 2. Theta is equals to tan inverse of 1 by 2. The theta, it has been calculated as 26.56 degree. So in this way we have calculated theta, which is 26.56. Next is angle made by this force. Again we have drawn the angle, that is alpha. It has been making with horizontal axis. So we have to find out tan alpha. So tan alpha in this case is, again we have to calculate it. That is nothing but opposite upon adjacent. The opposite in this case is 4. Adjacent in this case is, opposite in this case is vertical 4. Adjacent in this case is 3. Therefore alpha is equals to tan inverse of 4 by 3. So tan inverse of 4 by 3, it comes to be 53.13. Therefore alpha is equals to 53.13 degrees. Up to this concept is clear. So first we have calculated the angles, that is angle made by this force, that is F. It was given in the form of 3 by 4. So we have calculated the angle made by this force, and next we have calculated the angle made by this original x and y axis. Okay. Again we have to resolve this force F. We have to resolve this force F along x component and y component. Okay. So we have to find out the angle made by this force with x component. Okay. So here, but this angle, it is in the form of this horizontal. So how to transfer this angle with the total? So first transferring of the angles. So first we will transfer the angle, or we will find out how to transfer the angle. Transfer the angle. How we will transfer the angle? So there is a plane in this case. So first I am drawing this plane. Okay. So it is this is x axis. This is y axis. Okay. This is original x axis and y axis. How this this angle will be transferred here? So here we will transfer this angle. It is making with horizontal. That means this angle will be made with horizontal. Here it will be theta. Okay. So the theta value is 26.56, which we have calculated. So here in this way it has been transferred. Okay. So it will be transferred here, theta. Next is second angle. This was first angle and this second angle. The second angle is nothing but this. So again the plane is there. X and y axis is there. Okay. Here again the same force is there. Okay. Up we are transferring this force, which is making an angle of alpha with horizontal. So here there is an angle which has been made alpha. It is making an angle of alpha with horizontal. So here this angle will be transferred total. Okay. It will be transferred here, alpha. So this angle alpha will be transferred with whole as the alpha. So this whole angle will be alpha. Okay. The angle made with F with horizontal is alpha. That means on other sides opposite angle. The opposite is in the form of Z. So it is angle made with horizontal is alpha. So here we will transfer this alpha with here. That means this alpha, by mathematics law rule, it has been transferred here as alpha. Okay. So here total angle is alpha. That means this total angle is alpha. Okay. So this concept is clear. How this alpha it has been transferred here. How this theta it has been transferred here. Okay. So theta it is making with x axis. We have transferred with here. Whereas alpha it is making here. So I have transferred this. Okay. Again, what is theta? This original angle is theta. Okay. Theta is this angle and alpha is the total angle. So here this angle is theta. This angle is theta. So if we are calling this as beta angle, if we are calling this as beta angle, so how to find out beta? So beta is equals to this alpha minus theta. How to find out beta angle? that is alpha is the total angle from this point to this point, from force to this, and theta is this angle. Okay. So how to find out beta? This alpha minus theta will be beta. Okay. So alpha is 53.13 degrees minus 26.56. So beta it comes to be, the value of beta it comes to be 26.57. So it comes to be 26.57 degrees. Okay. So in this way we have calculated the angle made by this force with x-axis, with the inclined x-axis. So it is actually the angle made by this force with the inclined x-axis. Okay. The angle made by this force with the inclined x-axis. So this force is a, okay, the angle made by this force with inclined x-axis, this angle is 26.57 degrees. Okay. So here x-intercept is given. So first we have to find out x and y intercept. So fx is given as, x-intercept it has been given as 893. The fx is given as 893 newtons. So this x component, this is x and y. The fx is given as 893 newtons. So we have to use this 893 newtons, so x component and y components. So for this, what will be the x component of this? So if it is angle made with x-axis, so x component will be cos theta. So fx is equals to force F cos theta. These forces are known. What is fx given? 893 is given. Force is unknown. Cos theta, so cos, just now we have calculated the angle 26.57 degrees. Just the division is there. F is equals to 893 divided by cos of 26.57 degrees. So force it comes to be 998.44 newtons. The force comes to be 998.44 newtons. Same way y component. So Fy is equals to F sin theta. What about the sign conventions? So here this was x component and this was y component. Okay? So x component is upside positive, y component is again upside positive, and this figure itself indicates this is as positive. These directions are positive. F sin theta. So Fy is equals to F, just now we have calculated 998.44, and sine of angle is 26.57 degrees. So Fy component we have to calculate. So calculation of Fy component is 446.59 newtons. So in this way we have calculated x component and y component of this force. Okay? So in this way we have calculated x and y component of the force. Okay? So here we have completed this problem in which x and y component of this force we have calculated. So in which x intercept or x component was given 893 newtons. So we have calculated with the help of this given data, that is 893. We have calculated y component, and how this in today's problem. The most important concept was transfer of angles. How these angles will be transferred. Here this angle it has been transferred here. So I am drawing figure for this. So this will be transferred. Okay. This alpha will be transferred. This total is alpha. Okay. Whereas this theta it has been transferred here. This theta it has been transferred here. Okay. So we have calculated the angle beta. This angle as beta. This beta. We have calculated the angle as beta. So this alpha it has been transferred here. It has been making with horizontal. So we have taken this force with horizontal. This force with horizontal. The horizontal is this part. This total will be alpha. Okay. theta. Theta is again this x with horizontal, horizontal theta. So this total was alpha, this was theta. So alpha minus theta is this angle 26.57. So this beta we have calculated as 26.57, and this x intercept, this force with x component, this force is y component. Okay. So in this way we have calculated all the respective angles, and in this way we have calculated the y component. Okay? The y component of this force. So here we have completed this problem. Again I am having a second problem, in which I will first read the second problem, and we will draw the figure for this also. Okay? I am reading the second problem. Here the second problem is this part. The block shown in figure is acted upon by weight. Okay, there is a weight on the block. So there is a block in which a weight of 400 Newton, it has been acting downward. The block shown in the figure is acted upon by weight of W, that is 400 Newtons. A horizontal force F. So there is a horizontal force F. Yes, this 600 Newton, there is a horizontal force of 600 Newton, and a force P exerted by inclined plane, and a force P exerted by an inclined plane. There is a force here. Here this is a force which has been exerted on an inclined plane. Okay, which is which has been exerted on the inclined plane. The resultant of these forces is parallel to incline. The resultant of this force is parallel to incline. That means the resultant we have to calculate on these planes parallel to incline. Determine, that is force P and the resultant R. We have to find out this force P and the whole resultant R. Okay? Resultant is nothing but the calculations of all this. So here again in this problem the most important is x. Again it has been given in inclined. That means this x direction, it has been mentioned in the question. That means normal, we cannot take x that is in normal directions. Okay? That has been mentioned in the graph. Here x is in this way. So this upward side is x component, this side is y component. Okay, this x component, this y component. That means we have to resolve all these forces, that is 400 Newton or 600 Newton or force P along these two planes. That means we have to resolve all the forces along x and y plane. So x plane is this, upward direction is x plane, and right side upward direction is y plane. That means we have to resolve this 400 and P and 600 in such a way that we have to find out its x component, its y component along these two directions. That means if the force it is an upward direction, along this direction it will be positive. If it is in downward direction it will be negative. For y component, if it is in upward direction it is positive, and this direction it is negative. Okay? That means we have to resolve this for weight W Newton or force 600 Newton and force P along these two x and y component, that is in along this x and y axis, along this x and y directions. Okay? So always for resolution of forces or while finding out the x and y component, one thing it is to be kept in mind, you have to see properly the figure and along which direction we have to resolve, whether that force to be resolved along the given directions. So here it has been resolved along the given directions. Okay? The given direction is x and y. If it is not given in the question, that means we can resolve all the forces along the normal direction, that is always the direction in which we are resolving the graph. Okay? X and y axis. So first we will draw this figure. Question is clear. So everything it has been mentioned in the questions. So every forces it has been given in the question. So first we will draw this figure so that the calculations it will be made easy. There is an inclined plane. This is an inclined plane which is making an angle of 30 degrees with horizontal. That means this plane itself is making an angle of 30 degrees with horizontal. Okay? Again, perpendicular to this there is a block. Okay? That means this block yes, there is a block. Okay? Again, beyond this there is a force which has been given. This force, there is an inclined force it has been given. force P. It is making an angle of 45 degrees with vertical. This force P is making an angle of 45 degrees with vertical. Okay, and it is also making an angle of 75 degrees. So this angle is 75 degrees. What about the weight of block? The weight of block is also making some angle. Force F is 600 Newton. Okay, it is making an angle of 30 degrees. Whereas this force weight is always downward. W is equals to 400 newtons. It is making an angle of 60 degrees. So this data, it has been given in the question. So these things are given in the question. So with the help of the given data, we have to calculate the x and y component. What about the x and y component which has been given in the figure? So it has been mentioned in the figure. It's x and y component. So yes, this direction is given. This is x-axis. This is y-axis. Okay, this is positive x-axis and this is positive y-axis. That means resolve all forces along this positive x and y-axis. We will solve the numericals related with this. That means we have to resolve this 600 Newton along this x and y axis, 400 Newton along this x and y axis, P along this x and y axis. So we have to resolve all this along x and y axis. So one by one, first we will resolve this force P. This P is making an angle of 30 degrees which is perpendicular to the plane. That means this force P to be resolved along this x and y axis. That means I am taking this force P, the tip of my pen is the force P. So first it is making an angle with horizontal. So this component is parallel to this. Okay, this component is parallel to this. That means x component. So that means this force 600 Newton, it is making an angle of 30 degrees with horizontal. Horizontal is this inclined. Okay. So this component is, this force is F. That is directly I am writing as 600. As it is making an angle with horizontal, the horizontal component will be cos theta. And next component is vertical. So 600 sine of 30 degrees. Okay. Next W. W force is vertical, but it is again making an angle with this horizontal x-axis. This horizontal is parallel to this parallel. So this force 400 Newton are again making an angle of, it is a vertical force, it is making an angle of with horizontal. Okay. So that means this horizontal component again will be cos theta. This force, but it is downward. You have to see the arrows also. It is downward. So resolve this along these directions and along these directions. So this is 400, this, and it is making an angle with this, so this component will be cos of 60 degrees. Again, next, this component, again downward directions, this will be 400 sine of 60 degrees. Okay. So we have resolved 600 along x and y component, we have resolved 400 along x and y component, What about this force P? This force P, it is making an angle with this inclined plane. Okay. So we have to see inclined plane. This is just for confusing 45 degrees. We have to use 75 degrees. Why? Because we are resolving this along this component, x and y component. So x, y component and y component is a little bit in this way. So this x component for this force is along this directions. So this will be P cos of 75 degrees. Okay. Downward directions. Okay. This will be x component, and little bit in this way it will be y component. Small change, this will be y component. P sine of 75 degrees. Okay. Now we will find out its x and y components. Okay. We have to find out the x and y component of all the forces. One thing, it is been given. Now first we will find out all the x and y component for all the forces. First we will calculate its x and y component. Before that, the statement it has been given. What is that statement? I am once again reading that statement. The block shown in the figure is acted upon by weight W 400 Newton, horizontal force F 600 Newton, and a force P exerted by inclined plane, here force P. The resultant, yes, this statement is important. The resultant of these forces is parallel to incline. So here inclination is x-axis. This inclination is this. Okay. That means it is parallel to incline. That means this plane is inclined plane. Okay. So parallel to incline, that means a resultant will have the value of x component. The summation of fx is equals to resultant. Summation of fx is equal to resultant. Okay. So in this sentence, there are two meanings for this sentence. First meaning is that the resultant of these forces is parallel to incline. That means the resultant will be along x-axis, because inclined plane is x-axis. So resultant will be along x-axis. What about y-axis? So summation of fy will be 0. Summation of fy will be 0. So this line or this sentence, it is having two meanings for this. I am writing down the same sentence as resultant of these forces, as resultant of these forces is parallel to, it is parallel to incline. Therefore, what this statement says, it is parallel to incline. That means summation of fx will be equal to resultant, and what is summation of fy will be 0. Summation of fx is equals to this, and summation of fy will be equal to 0. So this sentence indicates these two meanings. Okay? fx is equals to resultant and fy is equal to 0. That means we have to find out all the horizontal component and then we have to find out all the vertical component for this forces. One by one we will find out all the x component and y component. Once again I am repeating, the x component is this side is x component and this side is y component. This means we have to resolve all the forces along these directions, resolve all the forces along y directions. Okay? First we are taking the forces which we have already resolved along x direction, that means along these directions. One by one. Force F along x direction, force F 600 Newton along x direction, yes, x direction 600, it is moving upside is positive, so plus 600 cos of 30 degrees. Okay, next force, only x component, yes, it is having y component, yes, this is x component, 400 cos 60 is x component, but upside is positive, we are having this in downward directions. Okay, so minus 400 cos 60. Okay, what about x component of force P? So it is having again the x component. While resolving we have to see the plane also. Okay, so tip is the direction for this force, this downward directions, minus this force P, minus P cos of 75 degrees, minus y because it is downward directions. What the statement says, summation of fx is equals to r, so that is equated with r. Okay, that is equated with r. And what is r given in this question? In the summation of fx, find out the values for this. So we will call this as question number 1. Next is summation of fy is equals to